Alright, so welcome back to Getting Started with C# and Unity. In our last episode we made a little button and a door that opens. In this episode we are going to expand our little playing area and make a boss chamber. And we're going to put a actual enemy in that chamber that drops a key to open another door. So let's go ahead and get started. We're going to duplicate our walls a little bit more. Let's go ahead and use our vertex snapping. Just a reminder, Control D on a selected object will duplicate it, and then you can hold down V and snap vertexes. Yeah, let's do it a couple more times. I'm going to select both of them this time and duplicate them. Ooh, fancy. And then I can snap this vertex here, saving time. Alright, cool. Let's put another turn here. If you want to make this a challenge for yourself, you could think about making some sort of maze for your game. That'll be an interesting little bonus mechanic. After I show you how to program this little boss monster that we're going to make, you can change the code any way you like and make your own monster. Okay, so I'm actually going to continue up here and make a little bit of a turn, and then I'm going to put the boss chamber somewhere around here. So I'm going to set this back to 0 since we're going back up. Alright, vertex snap. Alright, looking good. If you like, you could use different sizes and shapes and stuff of these rectangles here, but just to keep it simple, I'm using the same shape every time. Well, somewhat, just because it lines up better, like that. And here we can start blocking out our boss room. And again, you don't have to follow me step by step. Part of the beauty of game design is that it's just like any other art. You can do anything you want with the power of programming and art and writing and music and just so many fields of design. That's why I love it so much. We're gonna make a cool little boss chamber. Oh, Brad. Oops. Okay, so it's just kind of going to be a little square or a rectangle here. So let's go ahead and duplicate this here, rotate it. Let's set it back to 0 as well. Okay, 5. All right, that's good. I'm gonna make sure I got this on point here. All right, a couple more, and we will be done with this boss chamber, and we'll start programming the boss. And then we'll go across here a couple times. But you want to make sure that there's a opening here, because we're going to put a door that the player can use a key to open, and the boss will drop that key. So this little opening right here, perfect, absolutely perfect. So let's go ahead and block that off with a new little door. You can duplicate this wall one more time, just kind of like the one that we did last time. Let's take that out of the wall parent. Let's just call this lock door. Differentiate it from the other door. Now we probably want a different color for this door. I'm gonna pick gold because normally keys are golden, right? So you can associate a gold key with a gold door. Say create new material, call this locked door. I'm gonna pick kind of a golden color here. That'll do. All right. Make that a little bit smaller here. Oops, wrong one. I want Z. Perfect. Now you're gonna get a little bit of Z fighting here, but you can do the same trick and lower it down just a little bit so you don't get that nasty Z fighting. Perfect. Alright, so now we have our little boss chamber, a little locked door that doesn't do anything now but will soon. And now we need to start making our boss. So our boss, get ready for it. It's gonna be the most intense thing ever. A sphere. It's not just any sphere. The sphere is gonna track you down, kill you. It's gonna be a good sphere. All right, so I'm gonna pick a color for my boss. I'm gonna go with, I don't know, what rethink. Hot pink, because it's the most intimidating color. It's more of a purple, whatever. Let's set him down lower on the ground. 0.5 will be okay. Probably should go with 0.55, like the other one, just so he doesn't, fall through the earth. Let's go ahead and add a component, add a rigid body to him. Make sure to freeze his rotation so he doesn't roll around everywhere. Make sure he's using gravity, and we should be good. Okay, actually let's call him boss real quick. Boss. Alright. So, what we have so far is, if we go over here, hit our button, open the door, then go to the boss chamber, you can see him, but he doesn't really do anything. In fact, we can like bump into him, we don't die, hit the door, yeah. Nothing happens. Oh, we can actually push him around a little bit because he has a rigid body, but we want a boss that's actually scary. Chases us around, if we touch it, we die. And we can do that with the power of programming. So, let's go ahead and make a new script. Let's call it boss control. Let that compile real quick. And go ahead and drag that on the boss. There we go. Let me format this real quick. Okay, so we're gonna need a couple of variables here, and they might be kind of a weird data type, but bear with me and I'll explain it. So first we're gonna need reference to our player. Now how do we get reference to our player? Well, we can actually store our entire player as a variable. If you type GameObject with a capital G, this is important. This is a data type, while the small one, like this, that just refers to the actual GameObject that the script is attached to. So we want the capital G one, that's good. And we're just gonna call this player. And that's all you need. Doesn't even need to be public. Now in our start function here, the start function is only called once at the very start. So this is perfect for, like it says, initialization, where we get some basic things like references only once. So we're gonna say player equals GameObject, again with a capital G because this is returning a GameObject type. And we're gonna say dot find GameObject with tag. Make sure it's GameObject and not GameObjects because that returns an array. And now a parenthesis, and it's looking for a string. And you see how it says string tag? It's looking for the player tag. Make sure that P is capitalized, and then end it with a semicolon, and you should be good. So as soon as this starts, this variable player is populated with a GameObject that's tagged player, and since we only have one, if we compile it, it'll reference this. You say, okay, what do we need that reference for? Well, if we want our enemy to actually follow the player, or if the player gets within a certain radius, we want it to start moving towards it, we can do that with an if check and measuring its distance with the distance formula. Now you're thinking, oh god, the distance formula, how am I going to do that in code? Well, you don't actually have to because it's done for you. So all we have to do in the update function is say if vector3 dot distance, and there's a whole bunch of different things in vector3. I advise you just to hit dot and see what they all do because you can get a little bit of information here. But we're using distance for now. Distance, and now it's going to be accepting two things. It says vector A and vector B, and that's going to be the distance between those two things. Say, okay, what are these vectors? Well, first we can get one of them easily from ourself. We're going to say GameObject with a lowercase g, not capital, lowercase g. That refers to us. Then we say dot transform dot position, and that's our positional information, which happens to be a vector3. If you go to your player, yeah, 1, 2, 3, perfect. And now we need the player's transform position. So we say player, since we already have reference to it, dot, I'm not sure why I did that. Let's just copy and paste a variable. You might want to consider a better variable name than player, but for now it works. Player dot transform.position, just kind of like our game object here. So what this is doing is this is returning a float, which is the distance between these two vectors, these 2 points. So what we're going to do is, if this float right here is less than or equal to, I'm going to say 8.0f, then start chasing player. So if the player is within 8 units of the enemy, we'll start chasing them. So to test this, let's do debug.log, say player is in range, semicolon, and we'll go ahead and compile, and we're done. So as soon as we get within 8 units of this enemy, you should see in the console right here that I am in range. See? Player is in range. As soon as I get away, it stops. Now it looks like 8 is a little too close. Maybe we can back them up a little bit. Make sure to stop your game. Let's back them up just a little bit. So we don't want the player to get jumped before he even sees the boss. So let's lower that down a little bit, maybe 5. You can also turn this into a public float variable if you'd like to just change it on the fly. But for now, this is okay. So once the player is in range, we're going to want to look at him because we want that forward-facing vector, that Z right here, we want that looking right at the player so we can make it nice and easy to move towards him. So we say game object with a lowercase g because we're referring to ourselves, dot transform, and this is actually a really cool little function, dot look at, and it's with a capital, and now it's going to be asking for a vector to look at. Actually no, it's looking for a transform to look at, and all we need to do is say player dot transform because we have reference to the player and we have reference to all of his components. If you notice how that worked, see, we have the game object and we can take any component we want from it, especially his transform. So now the sphere should look at the player. So if we let this compile real quick, well, once it's in range anyway. Bonk. So if you notice this blue gizmo arrow right here, as soon as the player gets within range, that gizmo arrow should look immediately at the player. And it's not for some reason, so let's see why. Okay, let's take a look why. It looked like it didn't compile. Oh, I might have forgotten to save. Interesting, I thought I saved. Okay, that's why. I noticed my console was still saying stuff, but I was like, I thought I got rid of that line. So now it should work. Yep, see how that blue line is looking right at him? When he's in range, anyway. Okay, that's perfect. So now we want the sphere to start moving towards him. So since we have a rigid body on this, and we want it to abide by the laws of physics and not phase through walls, we're going to use rigid body dot transform dot translate. Oops, not transform again, that makes no sense. Translate, there we go. And we're going to move in the forward direction, so we say vector3 dot forward multiplied by time dot delta time multiplied by, we don't have a variable for this, so let's go ahead and go to the top, say public float speed, and just like our player, we can just set that to 1 for now and then modify it in the inspector. So we can take that speed variable we just made and put it in the end there. So now this should move the sphere in the forward direction, which is looking at the player at all times if it's in range, which means you'll start moving towards him. Alright, once we compile, I'll show you. There we go. Hit our button. Now we should start moving towards the player if he's in range. Yeah, there we go. Now we're following. He's a little slow, but we can change that in the inspector. Perfect. I'm going to up the range a little bit. This is why I said it's probably useful to make it a public variable, But with speed, I can definitely show you how that's useful, because then you can just change it immediately. Let's change the speed to like 5 or something. Should be going a little bit faster now. Okay, so now how do we make him lethal to the player? Well, we're going to need to do some collision checking. Now, this is slightly different from on trigger enter, because this is actually keeping his collision intact. You can still bump into him, and that's what's going to kill us. So go ahead and make a new function. Make sure that it's still in your class. Void on collision instead of trigger, enter. And then here it's going to be collision.other, not collider.other, collision. And then open, close. Perfect. And put a little more space here. There we go. Okay, so this is pretty dang similar to trigger, except that it keeps its collider. So we're going to say if other dot game object dot tag, see, it's very similar. In fact, it's almost the same. Equals player with capital P. So this is referring to the player's tag. If it is the player that I bumped into, we're going to reload the level, just so it's like an easy reset. So the way that we can do this is we can say application dot load level, and make sure that this is load level, not loaded level. You'll notice the capital L there. Inside here, we're going to say application.loaded level. That's where the loaded level comes in. So what this does is essentially it just says, okay, application, load the level that's already loaded, which will essentially just reset the map, which is exactly what we want. So now, once this compiles, actually no, there's one important step that you need to know. In order for application.loadLevel to actually load levels, you need to make sure that you've assigned levels here. So in your build inspector, so you go to File, Build Settings, Add Current. And this is very important, or else you're going to get an error. If you see this in here, you're all good. So now, if we go ahead and bump into this enemy, bonk, he should start ferociously chasing us, and if we touch him, poof, the map reset. Perfect. Okay, so in the next episode, I'm going to teach you how to defend yourself against this enemy by shooting projectiles. Also going to show you how to kill him and how he can drop a key so we can go through the door. Alright, thanks for watching.